fractions and decimals. Here is a warm-up question to be able to kind of remind yourselves about fractions and decimals. Sophia, Lucas are baking cookies and need to use sugar and flour for their recipe. They have 2 containers of sugar, one that holds 3/4 cups and another that holds 0.5 cups. They also have containers of flour, one that holds 3/4 cups and another that holds 1.25 cups. What is the total amount of sugar and flour combined? Write your answer as a decimal and fraction. So first you'll write out all the amounts that you have here. So it's 3.4 cups, 0.5, 6.4, and 1.25. Then you have to make sure all the denominators are the same. So this one is not. So you need to make the denominator a 4. So you'll multiply both the numerator and denominator by 2. Once the denominator is the same, which is 4, you can just add the numerator together, which is equal to 16. And when you simplify that fraction, 16 over 4, it equals to 4 over 1, which is equal to 4 cups, or 4.0 cups. Okay, so now what are the different types of decimals? It's important to sort of be able to know the difference and identify the different decimals so that when you are converting from fraction to decimal, decimal to fraction, there's a slightly different method you can use in order to convert them. I just see a mark here. I'm just going to erase that. Whoops. There we go. Okay, so terminating decimal. A terminating decimal is a decimal that terminates. For example, 2.75. A repeating decimal is a decimal that repeats. For example, 0.181818. And if it continues on, you can also write it as 0.18 with a line on top. A non-terminating, non-repeating decimal is a decimal that doesn't terminate or repeat. For example, 3.14159 ... which means it continues. Notice there's no pattern in the digits like the one above. Another way to show this number is pi. Therefore, this doesn't terminate and it also doesn't have a repeating pattern. Okay, so question number 1. State what type of decimal the following decimals are. So 0.333, the 3 is repeating, hence this is a repeating decimal. B, 1.125, it ends, there's no repeating pattern, it's a terminating decimal. One C, 2.1428, and then it continues with ... So it doesn't have a repeating pattern, doesn't end, therefore it's non-terminating, non-repeating decimal. Okay, 1D is the same, non-terminating, non-repeating. One 6, it repeats. And terminates. For the final one, 3.8, as it ends, and there's no repeating patterns. So how do we convert fractions to decimals? To convert a fraction to a terminating decimal, divide the numerator by the denominator. So if your question here, it says using a calculator, you can put into the calculator 3 divided by 8, and you're going to get 0.375. To do this, completing using a long division, you put the numerator here and then the denominator on the left side. So 3 divided by 8. So 8 goes into 3 0 times. You add a 0. 8 goes into 30 3 times. So 8 times 3 is 24. You have a remainder of 6. And add another 0. 8 goes into 67 times. So it's minus 56. You have a remainder of 4. You add another 0. Bring it down. And then 8 goes into 40 exactly 5 times. So the remainder is 0, which is also another clue that this is a terminating decimal. Okay, question 2. Convert the following fractions to decimals using long division, then state the type of decimal it is. So 12 divided by 5. Five goes into 12 2 times, minus 10, remainder of 2. 5 goes into 20 4 times. 5 times 4 is 20. And remainder is 0, therefore the decimal ends. It's a terminating decimal. Okay, B, 3 divided by 6. So 3 divided by 6. 6 goes into 3 0 times. Add a 0. 6 goes into 35 times. 6 times 5 is 30. The remainder is 0. This is also a terminating decimal. And finally, C, 4 goes into 11, and you can use a calculator to check. So 11 goes into 4 0 times. 11 goes into 43 times. So 11 times 3 is 33. You have a remainder of 7. Bring down the extra 0. 11 in 70 goes 6 times. So minus 66. You have a remainder of 4. Again, which you can tell that this is going to be repeating, because after you add a 0 to the 40, you're going to have a remainder of 7 and so forth. Therefore, this is a repeating decimal. You will never get to a remainder of 0. So how to convert terminating decimals to fractions. Step 1, place the decimal over its place value. Could be tenths, hundredths, or thousandths. Step 2, simplify the fraction. So example number 1, we have 0.2, so that's 2 tenths. So 2 over 10. Example 2, 75 hundredths. So it's 75 over 100. Step 2, simplify the fraction. So we started off with 2 over 10. If I further simplify it, it is 1 over 5. And 75 over 100, if I divide both by 25, I will have 3 over 4. So question number 3, convert the following decimals to fractions and simplify your final answer. So this is for 3a, 0.45, that's 45 hundredths. So 45 over 100. And if I further simplify this, it will equal 9 over 20. If I divide the numerator and denominator by 5. And if you want to check and verify, you can press the buttons below on your calculator with 45, then this button, A over B over C, sorry, A and B over C, and 100. And it should give you the simplified fraction, which is 9 over 20. Okay, so B, that's 0.625. So 625 thousandths, or 625 over 1,000, which is equal to 5 over 8. You can divide both the top and bottom by 125. And finally C, 4.35. So that's 4 and 35 over 100, which is equal to, we're going to keep the 4 and simplify the 35 over 100 fraction to 7 over 20. Okay, so how do we convert repeating decimals to fractions? Step 1, set the repeating decimal equal to variable x. Step 2, multiply both sides of the equation by 10 to the power of n, where n is the number of repeating digits. So notice here we only have one repeating digit, which is the 2. So 0.2, this is where we started off with, and we're going to multiply both sides by 10. The n here is 1 because the 2 repeats. There's only one digit, to the power of 1, which is equal to 2.2, continuation, repeating, and then 10x. So now, step 3, subtract x from both sides. Remember that x is equal to 0 point repeating 2. So 2 point repeating 2 minus point repeating 2 eliminates the 2 that repeats. So I'm going to start off with just rewriting the question here, or where we left off, and 2.2 minus 0.2, and then 10x minus x is equal to 9x and 2. Step 4, solve for x and simplify. So to solve for x means we need to isolate x. So we have to divide whatever x is attached to. Here it's 9. So the reverse operation of multiplication is division. So you're going to, just going to rewrite the question where we left off. Divide this by 9 on the right side and divide the left side by 9. Whatever you do on one side, you have to do to the other. Therefore, x is 2 over 9. And you can't further simplify it, so that's your final answer. Question 4. Convert the following repeating decimals to fractions. So I'll do example 4b here because in the last question, the number of digits that were repeating were 1. In question 4b, the number of digits that repeat are 2 digits. The 2, 7 repeat. So the steps are all the same. The only thing that's different is that you're going to multiply 10 to the power of 2 instead of 10 to the power of 1. So the first step is to set it up equal to x, then multiply both sides by 10 to the power of n, which here is 2, which is equal to 100x, and 0.27 times 100, you move your decimal place 2 spaces, which is 27 point repeating 27. So now we're going to subtract x from both sides. So x here is, let me highlight it. So the value of x is 0.27 repeating x. So if we subtract that from 27, if we subtract that from here, 27.27, we will be left with 27. So 27 is equal to 100 x minus x. Therefore, 27 is equal to 99x. So to isolate x, I divide 99 by 99. And whatever I do on one side, I do to the other. Therefore, x is 27 over 99. And if I further simplify that, it will be 3 over 11. Okay, question 5. Match the cards with letters with their equivalent representation below. Not all cards will be used, so unscramble the unused letters to create a word. So you can pause the video here if you'd like and try to complete the task. And you'll be left with 3 letters. And the 3 letters are, I'm going to pick a different color, pi, P-I-E. I hope this lesson was helpful, and have a great day.